I always started like that because when you watch this lecture later, it just yells at you. Um, I've heard students watching my lectures and recordings on the floor before, and I'm just sitting there, and all of a sudden hear, okay! And I'm like, oh, good job, you're watching it. So I know, but it's stupid. All right, hey, so check it out. Yesterday, you met a good friend of mine from Sesame Street, right? Cookie Monster, he came in and subbed in for me and taught you about sessions of cookies.
Yes.
Okay, cool. He's a good guy. Anyways, so we're gonna learn about auth today, kind of what he or she alluded to. And the idea is that auth is broken down to two parts: authentication and authorization. What are your thoughts on what the differences are? Because words mean things, yeah? How snarky of me.
So authentication is like it's coming from the right place, like a place like it's a message coming from somewhere that it should be. Then authorization is you're allowed to access things.
Right? The idea is that authentication is, are you who you say you are? And authorization is, what are you allowed to do? Which are very different. The best analogy I can give you is, I probably should have thought, like you're flying, right? TSA, who here has flown before or understand that process? Okay, the idea is this. Once you get there and you have a ticket that says Wangtron 3000, you have to go first authenticate who you are. Right? You have a ticket, the first thing that happens is some TSA agent comes up to you, having a great day, with a great attitude, says, hello, how are you? And they look at your ticket and they ask for what? They ask for some ID, right? You could give them any name you want. You're like, yo, it's me, it's your boy. Doesn't matter. They need ID. They need to prove, hey, are you who you say you are? And they look at ID. ID that has been already verified by the government, right? Like some driver's license, some sort of passport, something that says, hey, are you who you say you are? Once you are authenticated, you are passing through security. Can you get on any flight you want? I hope not. All right, that would be crazy. What are you authorized to do? You're allowed to go to one gate, one flight at a particular time, right? And so that's the difference. Authentication is, are you who you say you are? Authorization is, what are you allowed to do? What do you have access to? So far, so good? In the same way that some people, when they log in, they have administrative rights. They can go and do whatever they want, but you as the user, can you log into Twitter and delete somebody else's tweet? No, you're not authorized, but are you authenticated? Yes, and so there's kind of the difference there. And so let's, I usually leave this up, and then people don't listen to me because they think that this GIF is going to change somehow. They're like, oh my God, I wonder what's happening next. Nothing, surprise. It just loops. So that's kind of like what the basic theory is. What I want to talk about is best practices and being responsible. Because in the world that we live in today, we're in the beginning of the age of technology. This is such a crazy, beautiful, and amazing time to be alive, especially as a developer. Mostly because it's the absolute Wild West. They're now forming laws to figure out how we can regulate the internet. So you could take that as chaotic good. You could take that however you want, but the idea is this. What I want to teach you is how to be responsible and how to do it right. Because let's say you're building an application, right? You're on, I don't know, like Hinge, or I don't know, I think of dating apps. You're on Twitter, whatever, right? What is to say how they store and use your data? What is to say that they can't sell it or use it for whatever they want? What laws sort of say that? Right? Yeah, I know. Oh boy, Zuck is in trouble, right? But those are new things that are happening. And so the question I have for you is, when you're creating your app, your next trillion-dollar idea, and you have all these users, do you want to save the username and their password, specifically the password, as plain text in your database? Should I see in my database when I do user.all, ID 1, username, your boy, password 1234? Right? Most of you, thank God, are saying like, no, that's a bad idea. But is it illegal? All right, hey, that's not the point. It's not like a legal discussion. But what I do want to say is we shouldn't be doing that. And so what I want to talk about is this idea of like, how can we make sure that we're doing it the right way? So we've agreed that it shouldn't be readable. And we've talked about what sessions and cookies look like and how they're key value pairs and they're sort of scrambled, right? It's hashified. And so that it's not human readable, it's not human understandable. Would that be an acceptable way to store into the database? So if I see username Wangtron and I see password x to the z, actually understandable, but like xz4k9 $, hashtag, semicolon, thumbs up, would that make any sense to anybody? Absolutely not. It shouldn't make any sense. We should be able to hashify it and change it so it's not readable. But here's the tricky part. Once you transform it, you still need a reference to it because what is the user going to type in? Every single time? Like, all right, hold on. XZ, well, I don't even remember what it was, but like, are they going to type that in every time? No, it's going to be something powerful and unique and different for every account that you have, which I know you all do, right? Obviously. So you should do that, by the way. Please do. We'll get a password manager. But the point is, we need a reference to the old thing. Because if I put in Wangtron 3000 and I put my password as 123, it should somehow match. Think about it in code now. If I take 123, that comes across as params, right? In my form. I need to somehow look at the params password and check in the database against XZ semicolon 49 thumbs up. And I need it to be true. That's where the problem is, and that's what we're going to try to solve today. Cool? So there's this idea that there needs to be some sort of one-way transformation. So is anyone here like vegan, like vegetarian? Okay, so imagine you have this meat grinder, right? And you take in, I mean, sometimes it's a vegetable grinder, right? But I'll just adjust. And it's like a meat grinder, right? And you put in meat in there, right? And then you're just churning it out. On the other side, it definitely doesn't look the same. It is somehow smashed up, grinded, churned, turned, maybe a little burned, and it comes out the other end. Can you put it back in the meat grinder and have like a whole piece of steak meat? No, that's a one-way transformation, right, that we already understand conceptually in life. But is there a way to test that meat and being like, hey, was that pork? Was that chicken? Was that steak? Yes, right? You can. There's like DNA. There's all sorts of, you can look at it and be like, okay, it's red, not chicken. Got it, right? There's ways to sort of identify what it was. And that's what we need to do. And the way we do it, rather the way I'm going to teach you, is through something called bcrypt. Bcrypt is a standard hashing algorithm that is, in fact, one way. This is an acceptable standard. There are other standards out there. There's like scrypt, there's like your own hashing encrypting algorithm. There's so many different ways. Bcrypt is a widely used and widely acceptable and popular way of doing things. Cool? I just want to open your mind that like, hey, this is not the only way. Cool? So, what better than to look at the docs? So I just looked up bcrypt Ruby because we're going to use Ruby today. Powerful. What does that tell you in terms of bcrypt? If I had to look up bcrypt Ruby. Yeah, you could use it for so many different languages. Cool? So let's check it out. Boop, boop, boop. It's just a gem. Oh my god, the build is failing, which is embarrassing. Oh, but that's not important. We can talk about like build. Oh, what's this? Oh, passing? Wow, that is not clear at all. But either way, the point is we're going to use bcrypt today. So I'm going to show you some cool stuff. All right, let's get out of the the Rails app. I'm going to go back into the IRB, the old herb. Do you remember this? A little throwback, old school. Okay, come. If I wanted to pull in and use the bcrypt gem, how would I do that in like a regular IRB session? Require it. That's right, mysterious stranger. You can in fact require the gem. So I'm just going to require B, the capital C, ripped. Wow, bless up. All right. So if I do something like array, does array exist in Ruby? Yeah, right. If I require bcrypt, now this constant, I'm always bad with this, YPT, that exists. But have I defined a Jinkies class? Have I done anything with the Jinkies class? That's just a stupid thing that a very old cartoon character used to say. Jinkies, Z. What will happen if I attempt to call upon a class or a constant that does not exist? It says, yo dog, you uninitialized constant, that constant doesn't exist. That's what it tells you. So far so good? So what does this mean about bcrypt? Do I have access to it, yes or no?
Yes.
Check. So let's take a look at some of this bcrypt magic. Now I could do something like array.new, and that will make what? New array. Amazing. I can do bcrypt. Whoops. Oh, this is so bad. All right. .new. Who remembers the inheritance lecture? It was so good. Very good. Forefront of your mind. Think about it every day. Okay. What is this? Boop, boop, boop. Yes, namespacing, right? That means that there's some sort of bcrypt module, and inside that module there's a class that's defined. And since we're talking about usernames and passwords, there's a class password that's inside there. That's all this is. Cool? And what I want to do is I want to create a brand new one. Yeah? Normally I ask the class what's a good password, and then I have gotten some very specific answers, so I'm not going to do that anymore because it's being recorded. I was like, whoa, no, that was a bad idea. So I'm just going to use my password. 1, 2, 3. Please don't hack me. Okay? It's not my password for those that are thinking about it. Right? Cool. Let's see what comes back. Bloop. Gasp. Wow, thank you. Wow, right on cue. Amazing. Wow. What is that? Y'all saying a lot of things.
1, 2, 3.
So this is another thing we want to show you the guys can take, right?
Ooh, that's another spicy question. The question is, if I were to go, bloop, saw that no look? That's how you know you're good. It's just the up button. I like your class. Your class is really good. What would happen if I ran this again?
Create a new encryption.
No.
Do we want the exact same object to come back?
No.
Why?
You could just use that.
The idea is that if this came back the same, right, and I stole a database, I mean, theoretically, I could just figure out sort of a one-to-one mapping ratio of if it looks like EUL, I don't know why I tried pronouncing that, EIOULO, whatever, blah, 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 then I know that it's 1, 2, 3, and it's going to be the same every time. Because let's be real, sometimes it can happen in human nature that some people might have the same password, right? Like my password, let's just say it was WangTron3000, and it's not, or it's not. Please don't try it. Just don't try it in general. The idea is that, let's say my brother also, for whatever reason, favors this phrase and attempts to, I don't actually know if that's his password, but you know nothing about him, don't look me up. Wants to use WangTron3000 as his or her, that's my brother's, his password. I'm trying to be like appropriate, and then I like don't know where the line is sometimes. It tries to use WangTron3000, right? If somehow we both use the same bank, somehow someone stole this bank account database, and were to notice that the object comes back exactly the same, they can then determine that very easily we must have what? Same password. So let's find out. So that no look, I looked. It's embarrassing. Gasp again. So this is why bcrypt is very useful, because no matter how many times I do it, it will come back different every time. So this solves a lot of our problems, and this is why this is actually considered secure. Cool. Now, what's sort of like the next issue? What's the next issue that we can possibly think of, right? I have 123 as my password, and I get this hashified string. What comes next? Find
Find the match.
Find the match. I hear some mumblings.
So if it encrypts every time, we have to figure out a way to decrypt it at times as well.
Yes, the idea is we need to be able to decrypt it. However, if we can decrypt it, anybody can decrypt it, right?
Specific time-sensitive encryption.
So, if we can decrypt it, do I want this to ever become 123 ever? Do I want to put this back in the meat grinder and get 123? No, the idea is that it must be a one-way transformation. I should never be able to decrypt. However, I should be able to, and the word you're looking for is compare. Should be able to compare 123 with this weird object, and it should go yeet. Let's reveal our vote. It should say yes. It should in fact return true, right? So let's try it. Here goes nothing. Blue. Oh man, I am a clown. Boo boo. And I want to do, just so I don't type it wrong. You know what I mean? Sometimes those typos will get real sketch. Boop. What are we thinking here? We thinking yeet? Let's yeet that hall. I'm seeing some head shakes over here. Let's reveal our votes. No big deal. I know it's a mystery what I'm about to do. It won't work. False. Well, let me explain. Ready? If I did ha and I compared it to nah, what would I get? I better hope that's false. Otherwise, Ruby's in trouble, right? So this thing and that thing, there's no way that should compare. That don't make no sense, right? We need a way to actually compare them. So let's check. What is 1, 2, 3? What is the data type for 1, 2, 3? Interesting. Oops, just kidding. Embarrassing. Okay. Congratulations, you're correct. It's string. What is this? I'm sorry. Let me just do this. What is that? I'll give you a hint. If I did dog.create and I checked the class, what would it be? Yeah, dog. Yeah, woohoo. If I did something else, like boop boop dot class, what would I get? Okay. So if I were to do something like this, dot create on a. I'm not asking very complicated questions. Yeah. Let's check. Was that, I mean, like, you know what I'm saying? If I just did. Yeah? Same? Nothing crazy? Thank you. Nothing crazy. So if I did something like this, right? And if I know that this is a password, bcrypt password object, and I compared it against a string, what would happen? The idea is that earlier, what did I really do? I did this, right? And it came back as? So if I did, what would I get? I would get a string. So of course, when you compare string to string, that would never work. Right? That would never work. So I need to compare the classes. So what I can do is, what does create do? What does it combine the two methods? New and save. So if I wanted to just make a new one and not necessarily create it, I can just do boop, 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 boop. Oh no, embarrassing. Zoop. Let's do this. Dot new. All right, I'm just creating a Bcrypt object. What do I want in 1, 2, 3?
4, 5, 6.
4, 5, 6. Why does 7, 8, 9? No, I'm just kidding. What would happen here? What would that give me? If I did dot new on it, what would it give me? Let's take a look at here. And here. What would it give me? Dot new. Instance of Bcrypt password. Passing in some garbled string. This is my favorite part. Let's reveal our votes. One more time for good luck. Maybe the code was wrong. Bloop, bloop. Let's see what's happening. Bcrypt password.new passing in this garbled string should create what type of object for me? A string or no? A Bcrypt object? Interesting. Now let's do this. This is also my favorite part, just in case I get it wrong. Bloop, bloop. Let's reveal our votes. Thumbs up is true. Remember what I said about formulating a hypothesis? How important it was. How important it was. It works. It's always on. Man, that is a brain buster. Nobody likes that, except me. And you will too, once you know why. So the idea is that bcrypt password.new double equals 1, 2, 3 is true. However, 1, 2, 3 double equals bcrypt password, the exact same thing is false. Allow me to show you some specifics. When I do 1, 2, 3 and I do double equals, this is in fact syntactical sugar for a method call of double equals, taking in an argument of something like this. Does that make sense? Yes. Which means that, you got it. I'm calling the double equal on what class here? And I'm calling double equal on what class here? On the Bcrypt password class. Do you remember monkey patching? Where I can go into a class, like this for example. Class array. Ha 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 ha. And I can define a method called ya boy. Bloop. And it's simply gonna go yeet and return this cowboy. Anytime you're ready. Bloop. I'm sorry, it should put it. I always forget. I'm going to end the method, and then I'm going to end the class. So if I take any array and I do dot length, what would it give me? Should be 0. I mean, I'm not like doing anything crazy here, right? But if I did dot ya boy, what would happen? I could just go into any class, add any method. But what if I didn't define ya boy, but I redefined length? I can override it and make it anything I want. So let's take a look at the docs. Probably should have did this earlier. I want to say it's probably in library, probably in bcrypt, probably in password, some sort of module of bcrypt, some sort of class password. Wow. That's where the namespacing comes in, yeah? And let's see if we can find...
Can you make the right side look bigger?
Thank you for bringing that up. What is bcrypt doing?
It's redefining the equals and everything. And the passage or whatever compare that string that you created and set it to the secret variable. And check the
10 points to Gryffindor, but I'm going to say it out loud because that answer was correct. I'm very soft. And that is, the double equals is being overwritten and redefined. So, when I call the double equal on the string, I'm getting the string double equal. But when I call the double equal on the bcrypt password, I'm calling the bcrypt password's double equal. And they look the same, but they're in fact different. How do we feel about that concept? Okay, so string 123 is calling the regular double equal that you know and love, right? This is a direct comparison. However, if we look at the docs, bcrypt monkey patches, it overwrites the double equal and makes a new method. So when I call the double equal on a bcrypt object, it's not doing the same thing that it was doing on a string object. That's the whole summary. And so who feels more comfortable about this? Who wants to like blow some mod 1's minds, right? You're just gonna like, yo, watch this, son. Okay, or not, whatever. Thought you knew some mod 1 friends, you know?
So the hash secret on the that's not say that you think it's decoded, decrypted, and also compared it to.
I don't want to use the word decrypt because decrypt would in fact mean it's going back. Yeah, but it will do its own secret comparison. And if you notice, even though bcrypt in general, the gem is open source, there's a lot of information here that is not. And that's the secret sauce, right? So something I want to point out really quickly, and then we'll take a quick commercial break, then we'll come back and finish and write some real code, is there's this idea. What does this mean again? Bloop, 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 bloop. Instance, right? So every instance gets this attribute of what? At salt, right? The salt is the secret sauce. You put in something like 1, 2, 3. You put in something like password. You put in something like capital P at SSW0. You know what I'm saying? A slight dig at something, but either way. You put in a password. You have to add something unique and special to every single one so that when it runs through the hashing algorithm, it comes out different. So if I put in 1, 2, 3 and I add in a little bit of salt there, and it comes out, and I add in 1, 2, 3 and I add a different salt, going through the same algorithm comes out different. And that's why that works. The salt is comprised of many different things for many different people, for many different reasons. But I think one of them is like, if you're on a certain OS, it'll pull your OS version and the timestamp. But then if you're on like Windows, it'll pull like certain parts of your bin, your binary file. It'll pull unique stuff to you. So the only way to really decrypt it is you have to know the exact person's version at the exact person's time with certain files from that person's local computer, and you have to know the algorithm to decrypt it. That's why this is sort of safe. Don't quote me on that. Again, these are all like rumors and hearsay, because if that was actually correct, then somebody would like crack it, right? But that's the idea, that it's some sort of unique identifier that's sprinkled in every time. Cool? All right, are there questions on the bcrypt magic in terms of overriding the double equal? Why this is effective for us? Because we can hash it one way, cannot be decrypted. It's new and different every single time. And there is a way to check, using plain text, something that is hashified. That solves all our checks. That's why bcrypt is what we're going to go with. Cool? Awesome, great. Let's take 5, and then we'll come back and I'll write some code for you. All right? Awesome. I mean, you can clap if you want to. I mean, you know, I guess if you're. So now that we understand bcrypt, right, and understand that override, that double equal method, one-way hashing algorithm still can compare against the plain text. The idea is that we have to take the user's input somehow. Then we have to intercept the user input before we save to the database. And we have to run it through bcrypt, then save it to the database. That make sense? Like if I'm trying to log in, or no, sign up. It's like, hey, welcome to Bookface. You have 0 friends. Sign up for this app. You put in the username, maybe an email, social security number, credit card information, obviously, right? And then eventually it asks you for a password. Then you hit submit. We now know, magic of the internet, it's probably sent some sort of post request. Post to /users, very likely. We have to hit it in the create action. We have to stop it right there. We have to take the params, run it through bcrypt, and then run a .save to the database, right? We never want to save the plain text password in the database, as we just discussed. So far, so good.
That's a good question, because I know the bcrypt like essentially is turning into a gibberish, right? But then let's say, because I know when we do validations for like unique usernames and stuff, but then with this it will be unique every single time. How do we check if it's like let's say we're trying to enter a username that nobody else have already?
Why would you ever want to check other people's passwords when you're creating a user?
Like username, because you didn't say we want to store usernames.
No, we want to store the passwords
Oh,
as
only
hashified. Only passwords, yeah. I mean, if your username comes up as your boy in Facebook, it's like, I mean, y'all saw my GitHub username. Surprise! Evan Wang. Thank you. Jack thinks I'm funny.
I think Jackson.
Okay, all right, that was cold. All right, okay, that was bad. Let's do this. Let's jump right to it. Locali, oh, just kidding. Localhost 3000 / what is the RESTful route for making a new user? Users / new, very good. How'd be going there? Rutrow, we ran into an error. So let's take a look at the code. F.text field is for a password. So let's take a look at the code base. Ready? Boop, boop, boop. What file would this be in? What file would that might be in? Yeah? What line? Bless up to Rails, Lord Rails, what a great error message, right? So I'm gonna go right into my views. Uh-oh, I can't find it. Boom. Views, user, new. Wow. That fuzzy search in action, right? Did you see it? Okay, watch it at 0.5 speed. No, I'm just kidding. Yeah, it's just fuzzy search, right? It allows me to get to where I want to go quickly because I know what I want. That's how you can use that power. So, form for user is just username and password. Pretty standard stuff. But I'm getting into an error, and here's why. Let's take a look at the schema. Bloop. Bloop. What are the attributes of my users table? Password digest, right? Not just password. If we recall how Form 4 works, is it will do inside the text field something like this, bloop, dot username, dot whatever this is. It will attempt to call this method, correct? In the same way, it will do at user dot this method, right? That's how Form 4 is working under the hood. The fact is, this user is an empty object, and because it's empty, it notices that all the values are nil, so it knows that it's a create action. Versus if it was a Form 4 in my update, and the user was not nil, not an empty shell, it would in fact do an edit update because there's a user object that actually exists. Right? That's how Rails magic is working. So, boop, 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 boop. I don't know how tired I can get. Naturally then, if I have password here, and my schema reflects password digest, does this error make sense to you? Right? Error makes sense. So, how can we fix it though? What's the hackiest way you can possibly imagine of fixing an undefined method on the user class? I heard it. It's just, if there's a method that's not defined in the user class, yo, guess what? Bloop. Yo, dirty, right? But this will fix our problem. Check. Bloop. As promised. Wow. This is an important thing to note as you move into Mod 3, that network requests, the speed and time of them are unpredictable. Remember that. Network requests, the speed and time in which you receive the response is unpredictable. Sometimes your Rails apps run super fast, and then sometimes you have to cough a little bit, maybe get up, go to the bathroom, come back, and then it will send back the response. Cool? In the same way the internet works, network requests are unpredictable. Sometimes they come back like this. Sometimes it's like, yo, dog, I'm on my lunch break. Okay, just kidding, here you go. And then they'll give it to you. Cool? It's very important. So, we fixed that error. Where does this create user button go to? By default, right? I haven't done anything crazy. A post to /users, right? And post to /users will hit what controller action? Yes, create is the action, but the controller is the user's controller, the create action. So let's jump right to it. User controller. Fuzzy search. Don't worry about all this extra code. The first thing I'm going to do is I'm going to hit a bybug here in the create. Why would we need to hit a bybug in the create when the user sends their plain text password and it hits the params in create? What do we want to do?
Make sure it's given the proper parameters. Oh, encrypted.
Right, we want to intercept the password before it gets saved to the database, and then we want to run it through the bcrypt engine. Does that make sense? So I just put a bybug here because this is the intercept. So if all goes well, my name is Jeff, and my password is P.A. Rivers.
Yes.
Bless
Why
up.
is that safe?
P.A. Jack Rivers. Wow. I used this password in Jack's lecture like 8 months ago. 7? Oh my God. All right. You can ask him about it. He thinks it's hilarious. It's not funny.
It's not funny.
Is it though? Well, you have one person who thinks you're very funny, so that's good. Very good. Jinkies, I know. All right. I was expecting it up there. All right. Cool, we're at the bybug, yeah? What do we want to check? Yeah, check the params. Yes, we should check the params. Very good, everyone and mysterious stranger. They come back as what we want them to. Embarrassing. We come back as what we want them to be, right? There's a key of user with username and UTF, and the password as keywords. Unfortunately, that right now is plain text. We don't want that. We want to intercept it. Yeah? How does this attempt to save into the database? If I were to do user.create, what will it do? Don't worry about the strong params. Don't worry about that sexy stuff. What should this do? It will do something like username is going to be params at a key of user, but more specifically the key of username. Bloop. And then it will do something like password. It won't do that magic for you. It'll do what is given. And then it will do this. Add a key of params, add a key of user, and a key of password. This is what's attempting to happen. You're right. There is no attribute password for user. That's very bad. But there is a... Did you whisper that? Password digest. Yes, there is. And it will save. Do we want that in the database? Sorry, password's exposed. Very bad. Do we want this in the database? No, we need to do what with the params at a key of user at a key of password? Yes, we need to hashify, run through that bcrypt engine. So if you really remember your active record, right? We can just create a reader. Because what is this? A getter method, which can be built as a macro like this. Boop, boop. I tried to be cool, and then I had a huge typo. All my cool points. I just dropped all my cool points. All right, that's the getter. What's the other one? The setter. When I want to save, I need to intercept. So, bloop. New password. But what is this really? Is this hashified already, or is this plain text? It's plain text still, unfortunately. So, plain text password. Boo. And what do we want the password digest? This instance variable? We want the self.password digest. We want that attribute to be what? We want a brand new bcryptio passwordio create with what information? All right, the plain text password. That's what this is doing. It's going to attempt to try to save the password because our attribute is just called password in the form, which is going to call user.password. And then when it tries to save it, it's going to do password equals because it doesn't know any better. We have to intercept it. Save now the attribute of password digest, that's the hashified password, so that we don't run into this junk. Oops, this junk. When I set password equals, I really want to do password digest is now equal to, not plain text string, but bcrypt password, passing in the plain text string so it becomes hashified. In the same way that if I were to do, oh look, user ID, user.find 13, fancy, dot password digest. Ugh. Let's make it now. Boop boop. With what it actually was. Bleep, blip, 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 blip. Interesting. And let's do user.find 13 again. What happened? Oh, I didn't save it. I know I'm missing something. I have to do dot update, yeah. But this is the idea behind it, right? I was just trying to show you, and then I made a boo-boo. Everyone does. It should be dot update. Cool. So that's basically what's happening. So far, so good. So we were able to intercept properly, and we're able to now store it into the database. The last part of this lecture is this idea that I need you to think ahead conceptually. This is where your Rails mastery really comes in handy. And that is, when you log in, what do you send over? Your username and your password in plain text. All right? Your username and your password in plain text. So part 1 is authenticate. Part 2 is authorization. So we need to build some sort of authenticate method in here. Because what's going to happen when the user hits the controller action of login? When I try to log in, it's going to go to maybe what? Post to /login, and it'll hit some controller action. That's not important right now. We're going to talk about that this afternoon. It's going to hit some sort of controller action. In that controller action, what do you want to happen? Right, when somebody logs in, you want to authenticate them. So we're going to build this method. This method will take in the plain text password. All right, so I'll reveal it for you. Earlier we learned about how to persist data from request to request, and that was with what? So naturally I have a, cool. I'm going to create a brand new session. That's the post to login. I want to do something like user.authenticate in here. So let's build that authenticate method. It will take in the plain text password. And what does it need to do? How did we compare the string against the bcrypt object? What do we need to do first? Can we compare string to string here? Will that make sense? What do we need? Okay. I could see you're tired and you want to go to lunch. Password.new. I don't want to make a brand new one because that will attempt to try to save, right? I just want to make a new one, not save it. So new, not create. And I want to pass in what? Right. What's actually in the database? So remember how it worked. I passed in that crazy string in here. Then I compared that using bcrypt's double equals, not the string's double equals. So if this order is wrong, it will matter. The plain text password. So if this is true, I want to say maybe true. Maybe I want to give the object back and like, hey, here's the user. Else, something like puts nah dog, try again. Cool. That's what the authenticate method does, right? Like, hey, is the password good? It's not, yo, try again. If it's good, great. I've authenticated you. This returns either the object or true. True or false, right? Who likes being upset? Okay, that's all this does. This one method will build all of this for you and a validation. And that is validates password. I want to say present. Just kidding. Sure. Oh, I'm sorry. It also does that. Yeah. Sorry, I wasted an hour of your time. Right? But the idea is now you understand it. That's more important to me. Because anyone could use that, and then when it breaks, what happens? They have to take it to a developer. Right? It should be you, the developer. Cool? All right, go to lunch.